everyone. How is EuroPython going for you so far? Good? Yeah? It's awesome. It's awesome. It's a great event. My first time here, but I enjoy it a lot as well. And honestly, with this keynote, I feel quite a bit of imposter syndrome because I've been programming for a long time, but only for less than a decade in Python, on and off. And I have just one package on PyPy, so I'm not one of the core maintainers or popular package maintainers. And there are people from the core Python team speaking here, and Sebastian, the author of FastAPI, will speak here, etc. So I'm quite humbled to be here. I guess I did build some interesting stuff during my career, and for the last 8 years, I've been co-leading Rossum as the CTO, and we built quite a large code base in Python. So what I want to talk about is what happened, what were our experiences, and this will be this hodgepodge style of a keynote where I'm really going after giving you some flashes of inspiration. Maybe you'll have one, maybe you'll have 15, but I hope you'll have at least one flash of inspiration today. And I'll be talking to Python users. If you are starting your journey, if you are maybe starting a startup, or you are building a code base in a larger company, you have a lot of decisions ahead of you. And maybe this will give you some interesting perspective on some of them, in case your code base will start scaling up. And I know that there is also a lot of Python maintainers in the audience. And I guess it might be interesting for them to hear what projects there in the wild, maybe not necessarily open source ones, etc. What do they struggle with as the code bases grow? But ultimately, I will be talking a lot about Zen of Python. And it's a bit of a meme, honestly. It is half joke, but half serious. But I think it's a really useful perspective for asking questions about your work, about your code base, and how you build things. So we will use Zen of Python as the framing for this whole thing. I want to get one thing out of the way. So our company is called Rossum, and you must be wondering right now, so is this Guido van Rossum? Are we named after him? And not really, actually, even though with this name we really have no choice but to build using Rossum. But actually, Rossum is used in another context in the world of technology because Karel Čapek was a Czech playwright who wrote Rossum's Universal Robots and introduced the word robot to the world. So it's based on actually his Rossum, because it's a similar word to word rozum, which is like mind in Czech. I think I named this talk quite awkwardly, so you might be thinking, okay, something around AI, hype, software as a service, product, what are those buzzwords? You might be cringing a little right now, and I don't blame you in that case. So I just want to take 2-3 minutes to demystify what Rossum does. I will not be selling you anything because, frankly, we do not sell to developers. We sell to large companies, mainly to finance departments, etc. But I just want to set the context in 3 minutes what we will be talking about regarding practical problems. So one thing that's happening is that 1 billion invoices are exchanged in the world every single day. And probably this figure is larger now, and there is a lot of other crazy documents besides invoices also exchanged in the world. So there is this whole thing going on, and processing those documents related to transactions and supply chain between all the companies in the world to get your notebook on your lap or on your table is totally crazy because there is huge amounts of manual data entry. There are people sitting in open spaces 8 hours a day, 5 days a week, just typing over information from pieces of paper to computer. Then they need to match all this information with whatever the vendor ID is in their SAP. Meanwhile, each invoice looks differently, and yes, some of them are in XML, but no, there are no incentives for the sender of those documents to use any unified formatting, so that doesn't really help. And then you get a document as a company, and something is wrong on the document, so you need to communicate back to the vendor. you need to pick up a phone or start writing an email. And meanwhile, those business transactions where your laptop vendor is ordering parts for their notebook, they are on hold. And they are stuck at some backlog for weeks until all this is sorted out. So this is wasting a lot of people's time in the world, administrative around those supply chain transactions between companies, and it makes the whole world go slower because of this overhead. And our goal at Rossum, what we are solving, what our product is just so that one person in a company can admin 1 million of those transactions per year. And that means they can even just see only about 3% of those business transactions of those documents. And 97% of them, no human can see for us to achieve this. But we think this is still reasonable, especially in the age of AI, etc. We have been fairly successful at it. But how would you use Python to solve this problem, right? Let's just walk through the high-level architecture if you have a problem like this, automating how companies talk to each other. So first, you need some AI engine, something fancy, smart, that figures out what's on the incoming documents, even though each document looks differently. Then you need to manage your documents. So you need some database. You need an app for people to actually check if whatever the AI figured out is correct, etc. You need some life cycle for those documents, and someone might need to approve them in a company, etc. So fairly standard web application. And then you need sort of middleware with the rest of the world. You need an integration component because those documents, they are coming by email to the company, and then they need to go to some SAP, right? And at the same time, from the accounting software vendor, you might need to download some databases of valid senders or items that you match on those documents, and you need to mirror them locally so that you can match stuff back and forth. So if we are making a technical decision, how do we implement those different components? We might have actually quite contradictory requirements. So the AI engine, something based on PyTorch, some minimalistic microservices focused on deep learning and inference and stuff like that, a lot of job queues, just connecting them together. Then the document management app, that's like a model case for Django, where you have essentially this CRUD web application. You have a fairly complex hierarchy of objects. All those objects are serialized in a database. Then you have some workflows and a lot of REST APIs for the front end and for external developers. And then you have the integrations, where it's all about just sending a lot of data back and forth, scaling those data transfers back and forth. So you really want to validate your data. You really want to do this async because it's completely IO-bound stuff. And it's something that just needs to be scalable IO. So that's kind of core of the dilemma for us, for example, at Rossum. How do we reconcile all those things, and how do we make this work together? Can Zen of Python help us to make some decisions regarding this? By the way, if you don't know, if you open your Python interpreter right now and just type import this, that is what you will see, the tenets of Zen of Python. And I'm just actually curious, can you show me your hand if you are familiar with this, if you have read all this? A lot of you did, like 2/3, I would say. Let's try something. Let's meditate for a bit. What do you say? And let's just internalize this, because we will be talking about this for the remaining half an hour. So close your eyes. Let your body rest. And let's listen to it together. You can listen to my voice. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. But complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although the way may not be obvious at first, unless you are Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. And namespaces are one hunking great idea. Let's do more of those. Thank you. You can open your eyes now. What do you think? Inspiring? Maybe it's a question, right? Because actually the interesting thing about Zen of Python, as any kind of Zen, is it's actually contradictory. It doesn't give you a recipe for your decision, but the purpose of this isn't to give you a guidebook and a dogma, a Bible that you follow those rules, and you will have clean code that's scalable and never breaks. Unfortunately, that's not it. But it tells you to ask questions. And there will be a lot of reconciliation of contradictions, but that's part of the process, and there is no simple recipe for this. I will be talking about our experience at Rossum, building those three components, reconciling them, some good lessons and some bad lessons, or some good experiences, bad experiences, through this viewpoint of Zen of Python. I will focus on a couple of those. Specifically, I would love to go through all of them because I think there is some lesson that we have learned for all of them, but feels to me that those are the most useful ones. And there is 19 of those here because the original author reserved the 20th for Guido himself to specify. Unfortunately, it was never written down, so we will never know. But I took the liberty, and I think you too can, and figure out one extra tenet for you. For us, my tenet would be that specific is better than general until you have seen it 4 times. Why 4? I will talk about that a little. But it's yeah, it's one that I feel has bitten us a lot. I'll be also a bit spicy for the rest of the presentation sometimes a little controversial, and you might want to disagree with me actually, and if I start some discussions around this between the audience here, I think that will be, I will feel like I have fulfilled my purpose here, because it's all about discussion. So let's see. Let's talk about those 7 lessons on practicality and purity and how to balance that in the way of Python. By the way, this morning I learned that every keynote should have a picture of a cat, and this just felt like the perfect place for it. So here is your cat. Even though personally I'm more of a guinea pig person actually, but did you know that guinea pigs can purr as well? So here is a guinea pig as well. But meanwhile, let's move on. So explicit is better than implicit. As many others, it is all about readability, about the tenet that readability counts and it contributes to it. By the way, I've learned on Discord, if you have trouble with Wi-Fi, this is the Wi-Fi password, apparently. Of course, the first way someone can think about is, how does it look on code level? How should your lines of Python code look like? And on the code level, like, again, everyone has to answer this for themselves, but popular examples are you shouldn't import all, you should import asterisk, you should keep those namespaces that are hunking great ideas. You should think about positional versus keyword arguments, and it's all around the fact that code is actually much easier to write than read. So when we talk about readability counting, this is one great way to ensure it, because when reading it, you don't have to guess. It takes longer to write, but just much easier to read. On architecture level, I think the most obvious idea is that you should consider whether you need a framework to do something, whether you need that library, whether you need that dependency. Maybe it's simple enough that you can actually code it yourself. Of course, when you code things yourself, there is a risk of a bug that someone else solved. But I think this risk just shouldn't overweight 100% that you don't have this external dependency. You can actually go into the code, debug, or change it as you need. And here's an example from a different ecosystem. I didn't find one on PyPy, so I guess we on the Python side are doing better, but there is this package isOdd on NPM, and it literally just does that one thing that you think it does, pretty much. But look at the number of weekly downloads. It's like 500,000 per week. It's crazy. It's a surprisingly popular package. So consider not doing that. just write the code yourself. Okay, that one was pretty obvious, but things can get less obvious. So, for example, our AI engine has 19 components, 19 separate microservices. Each of those microservices takes care of stuff like detecting text on an image or extracting information, then assigning some confidence scores to whatever the AI extracted, some on-the-fly zero-shot learning based on user feedback, and so on and so on. There is a lot of them. Each of them is kind of this event-driven queue-based service or web-based service. It has some managed lifecycle, so it needs to connect to external resources and so on and so on. And of course, what we could have done is we could have combined Dramatic and FastAPI, maybe Ray, and all those frameworks to build something on top of them. But we didn't do that. We actually wrote like 5,500 lines of code, which I feel is actually quite small. Built it on top of some low-level components, Workzug and RabbitMQ. I'm not saying you should rewrite everything, right? And what we did is we had a very small code base there that's tailored specifically to what we know we need to do at Rossum in our cloud environment and with our data environment. All the engineers in that team know this code base in and out, and it's so easy to hack it, to debug it, whenever we need to do something. So I'm wondering right now, how many of you are thinking like, are you crazy? Like, why aren't you using those frameworks? Those frameworks are amazing. But I think you might think that, and if I start this controversy, I'm actually happy. Use this as an opportunity, because I personally always have trouble talking to people on conferences if I don't know them. So next coffee break tomorrow morning, turn to your seatmate and ask them, is this guy crazy? Have you ever done something like this, or should we all use frameworks? And let's see what comes out from those discussions. What this also means, though, is we still did it pretty quickly. And by the way, we don't need to iterate a lot on that code base. There's like, we wrote this like 3-4 years back. Since then, there has been like something like 150 commits. And over the period, our total in that repository was 40,000 commits. So it's something that's actually fairly stable. But we got a service base, ASAP, and we still have this shared code where we can concentrate all this boilerplate, where we have all this monitoring logging set up, the shared I/O, where if you decouple I/O from business logic, by the way, it's really easily testable, because then you don't need to mock actual low-level operations. So it's a kind of sans I/O approach, right? So this is another tenet, that simple is better than complex. And for me, one thing that it means is actually finding those shared patterns and simplify for them. So think about your code bases. What are some things that you could simplify right now? I think we are hitting our first contradiction here, though. because I talked to you, don't use frameworks if you don't need to. I also told you concentrate boilerplate. Isn't external dependency sort of like shared boilerplate across community? And yes, there is this contradiction. The question is, I really like this tweet by Gergely Orosz, who says that code is a liability. It's like a week-old tweet, where the thing is, you want as little code as possible, because every single line of code that you have is a headache. Someone needs to understand it. It can have bugs in it. It increases the system complexity. So honestly, right now at Rossum, we are at a stage where the things that we almost celebrate the most are when we delete big chunks of code, when they aren't needed anymore. And I think there is a lot of projects like this. So then the question is just, you have this liability of having code, but if you have dependencies, those dependencies have 10 times more code than you would have locally. They can also have bugs. Sometimes something breaks within this dependency and you have those tracebacks that go through 3 different libraries. Is it worth it? And you need to answer that question for yourself, right? But you should think about it. This leads to the question when you should actually concentrate all this boilerplate. And here I will use this custom Zen tenet that we have that I invented for Rossum for the purpose of this presentation, and that's that specific is better than general. Until you have seen it 4 times. And I think this has been one of the most painful things, most painful mistakes that we did at the company when growing the code base was generalize too soon. The simplest example is you have a base class that implements some abstract behavior, and then you have the actual implementation. And I have seen many, many examples where actually you just have only one single specific class ever, and the base class is just extra headache when you are reading the code. It's not contributing anything at all in practice. There is this term in extreme programming that says you aren't gonna need it. And it's meant especially for this. Don't write extra code just because it's pretty, unless it actually helps your code base. So I don't know if you have similar stories from your companies, but when I look at the things that were most painful and we are most glad to get rid of them, it was this generality that we actually didn't need at the time. For example, we created our own machine learning pipelines library because we have this kind of interesting case. When you process a document through Rossum, it's a job that takes like 30 to 90 seconds, let's say. And when you think about the job queuing libraries, there is 2 kinds. One is for really fast jobs, like up to a second or a few seconds. And then you have another type of libraries that are optimized for jobs that take minutes to hours. And they really, they are more asynchronous, but they really take a long time to spin up the workers, etc. But we need something between that. And we also wanted something as elegant as Keras, for example, where it's really natural to express the dependencies. And something that can be like, we can actually serialize it per user. So each customer can have their own pipeline. And then we can separate these different services. It was all very pretty. The problem is we did that when we didn't have yet 4 different machine learning pipelines. Honestly, we didn't even have 2 different ones, or I mean significantly different. And when we introduced a new architecture, we just realized it's not working at all. And actually, when you want to reuse a component, you don't actually in our pipeline do it twice. If you start serializing too aggressively, it freezes the API of those components, so you lose a lot of freedom. And anyway, any improvements you do for users, you need to touch this code anyway. You don't just modify those configuration files. And the services, in the end, don't map to individual operations neatly, so you cannot do that either. So we ended up creating this library, investing a lot into that, and then deleting it again because we didn't really think through whether this is the kind of generality that we need. We thought we would, but in the end, it was a bit different. Another example of this is, and I'll be just kind of brief here, but we were those 19 services that we had in the AI engine, we were defining how those services behave using YAML configurations that describe, okay, there is this queue connected here, connected there, etc. And in the end, there is like the actual service plugged in somewhere deep into this interconnect configuration. But it didn't make any sense because you could have had all those defaults in your code. There is this concept called convention over configuration. Ruby on Rails got it really popular, but there is also nowadays a lot of Python libraries that are really heavy on this. For example, this is how dramatic differs from Celery, or part of it is this, etc. And the point is, you should not have useless configuration. Just put it in the code. And the configuration that you have should be kind of loosely coupled. In the same way, it should be shielded from implementation details, just as if you have two different components that you want to loosely couple, so that if you modify one, you don't want to think about the other. You want the same as the relationship between your configuration and your code. And ultimately, it boils down to the fact that code is almost always the best expression of logic that you can do. There's like one more example of that. When users use Rossum to process documents, we introduce those fat JSONs where they can express, okay, how do we actually modify this one value so that it's normalized, it has pretty values. But then now we are trying to scrap all this. Instead, we figure out how can we plug in Python to all this in some sandboxed way so that they can just write a line of Python. We didn't do that at first because we realized that actually finance people really hate programming for some reason. And they feared even Python, even this simple Python. But nowadays, even a year ago, LLMs were actually already good enough to reliably translate those small snippets. Even Claude Haiku was good enough to do this reliably. So to them, we can just present natural language. So of course, the question there is, but what about the sandboxing? If anyone can write any code, how do you shield this? But there is nowadays a lot of out-of-the-box ideas for this. There was this talk just a little before about WebAssembly as one way you can also use containers, Lambda functions, etc. If you figure it out, you will have a bit of overhead, but it will still be worth it, right? Let me not talk about Polylith. It's, so still, there is this contradiction. So should I go for simple? Should I go for complex, but at least not complicated? Should I be explicit? Should I build general code? And I think we still get it wrong a lot. We as programmers, even we at Rossum, we try to learn our lesson, but we still somehow get this wrong sometimes. But when I was thinking about this philosophically, I think the root cause lies in one of my favorite quotes. It's from the Harry Potter and the Methods of Rationality. And it's about having ideas. Because I think for a lot of us, it's the problem, our problem is getting a good idea. Because especially when you stop being complete beginner and you start having those good ideas, how to make something beautiful, how to introduce this fancy general architecture that will be super flexible, etc. It is a beautiful, good idea. The problem is if this is the only good idea that you have. What you should do is you should think about more good ideas. And that's, I think, where a lot of us fail often. So my lesson as a CTO, and honestly, when you work in a software engineering team, this is super helpful because you need to discuss and exchange your ideas with others, so it kind of forces you. My big lesson is when you get a good idea about how to structure your code, do not stop there. Keep thinking other good ideas, and then compare them with each other. Because a lot of those problematic things, bad architecture choices, I think stem from people who get the first good idea, then they stop, and they don't think the second one, the third one, and compare them. And the other thing is, of course, challenge if it's really needed, because as the extreme programmers say, you don't really need it, probably. So especially when there is a need for something to be flexible, it has a huge cost. So think about that, whether it's really needed. Two lessons remain, or is it three? Yeah, I think it's three. One thing, one part of Zen of Python that I think can be a bit mysterious for people is this now is better than never, although never is often better than right now. And the point there is, you should just, if you get an idea, you shouldn't overthinking. You should just try and do it now with your current setup, with your current framework, just see what happens. You might not even need to commit it, or you can just keep it in a branch. Doesn't really, but just prototype it, just try it out. However, you should think twice whether you should do the thing at all, especially when you try it out and see all the implications it has. And the fact if you are working at a startup or at a company that is growing really quickly is usually people want a lot of features from you. And there is this fact of life that lots of features quickly means a lot of depth, technical depth that you are taking, and you kind of need to deal with it. But it's good to put in some hard constraints, some principles early on, so that you can actually deal with it later for reasonable cost. And I have two that occurred to me and people in Rossum that I talked to. One is you should always have in place some great telemetry to understand how are actually people using your product. Stupid things. For example, we have official SDK for our API. We don't set a custom user agent in this SDK. So we don't know which of the API calls are actually made through the SDK and which of the API calls are done differently. So simple things like this. And you should really think when you introduce something externally, if you don't add extra concepts that are hard for your users to grapple with, etc. I have one example of ours. So we introduced this way to filter documents that come through Rossum, and we said, okay, how do we use some flexible filtering? And we decided that let's use MQL because it's easy to parse, it's standardized, many people actually know it. So we now have filtering through MQL in our API. Meanwhile, we also have a way to group some data in Rossum API using SQL statements and a different query language, because it seemed like a good idea. It's kind of like natural representation of things, etc. When I was looking and researching this slide, it surprised me actually that we also recommend in our documentation that you could use some custom Python code and pandas data frames to aggregate data. And then someone comes and says, look, people are actually very familiar with Excel. So product management idea could be, let's actually also introduce Excel expressions to manipulate things. So we didn't do that last one, but it was seriously considered at one point. In the end, we just went with Python and those LLMs. But you should really think about policing which external features you publish out there, because that's a bit of a one-way street. It's really a lot of work to deprecate things. So it's just a huge headache if you don't do that. To start wrapping things up, you should think always. There is this nice quip that every software engineer should understand at least one level above and one level below in the stack they are using. So if you are using JavaScript, you should also understand some HTML stuff and code and styling, of course, and you should also understand network transfers, for example, and HTTP. I think it's also good when you are doing something that has potential to grow to think one or two corners ahead. So, for example, you are building this Django application. Everything is in a single database, under a single domain, a single sequence of IDs. But there will, at some point, come a customer that will want a separate database. And if you at least don't design how you do your object IDs, etc., to be compliant with that, you will have huge headaches at that point, and something really cheap for you to do early. So think about things that you do early that are cheap like this. The thing that really worked for us, we didn't do this ID thing correctly, but what we did correctly is we kept policy separated from mechanism. This is principle from Linux kernel. Linux kernel, when you do things with the network or whatever, it separates the mechanism which does all this packet routing stuff from the policy which configures how exactly things should be done. And there is always really strict separation, and I think that's a great software architecture pattern overall. So easy thing you can do is when specific users will start approaching you with specific requests, think about the hook system to enable them doing this in their own custom code, just being hooked at the right moment. We did something like that, and it was actually super useful for us. And you can customize with just four or so hooks. There is more now, but like 3, 4 are essential ones. You can customize for different companies. You can really customize how the system behaves for them if you think about this right. Of course, you should be learning your lesson. Start just with the hooks that you need now. Don't overgeneralize. But this is something that really worked out for us. I want to end with the last tenet, that there should be one, and preferably one, obvious way to do it. And I think that's one of actually the most controversial ones. It guided a lot of Python designs, especially early on, and that's why Python is not Perl, hopefully, thankfully. But it's really difficult to do this in the real world, right? And of course, the authors of Zen of Python knew it, so one easy way to see that is actually there is 2 different ways even how to write dashes. Either you use spaces in one spelling standard to separate them, or you don't in a different one. So, of course, you can compromise and just do both. I don't know if that's better than choosing one and sticking to that. Of course, as I said, the whole Zen of Python is a bit of a meme and shouldn't be taken super seriously. Did you know, by the way, that you can import anti-gravity in Python? It's very useful. But in our context, so we have those 3 components, the AI engine, the document management app with all those databases, and the integrations with all their async APIs. So we have a choice, like what technology do we actually use? Do we just use native Python? Batteries should be included, right? So we have data classes, we have some like simple frameworks like Flask to wrap things around, etc. Or we can go Django way. We will have very fast, very good first version of the database app, but we will be in a bit of an idiosyncratic world where it is isolated from the rest. It's really difficult to mix and match Django stuff and non-Django stuff in many cases. Or we can go the new modern way, Pydantic, async, FastAPI. I'm really looking forward to the keynote tomorrow. You have some strongly typed I/O. It's nicely composable, but still, it's not fully compatible with other ways. So you have this choice. What happens is you have 3 different teams, and each team chooses the thing that works best for them. And then each team chooses differently, but that has its own headaches, right? You have one more choice, whether you go sync or async, of course. Which is a kind of, yeah, I see a lot of discussions around this, and it's a tough choice. So, yeah, do you go just Flask and minimalistic stuff? Do you go Django? Do you go FastAPI? There is, of course, you can go with different things, but then there is an architectural challenge. If you want to have a single cohesive project, maybe even with some shared libraries, it's actually quite complex to do this right now because there are large chunks of Python that aren't very well interoperable. And that's a shame, I think. Also, there's a bit of a provocative question, to be spicy again. It's not clear to many people I talk to if Django has a long-term future in all this. And I'm not saying technically it doesn't. Honestly, I have no clue. But all I'm saying is Django might be having a bit of a branding problem right now. And Django maintainers should think about, yeah, what vision for the future do they give people who would be thinking right now? Do I go FastAPI or do I go Django, right? And then there is some code challenges, especially with the async. If you think, do I go async, do I go many threads? It's a mess. To go with async is actually very laborious right now. I looked, it's a 10 years old feature already. But for example, Python standard library, if you just open files, it's not async ready. Of course, you have AIO files that actually open threads on the side to get this done for you, but isn't it awkward, crazily? And then you kind of need to choose. It's really difficult to mix different types of code. And for people working in large Python code bases like us that would like to choose differently in different cases, it's really a big headache. Even for our SDK package, we actually have two different clients. One is async, one is sync with very little shared code. It's like, of course, you can go the SaaS AI route, but it's really a really awkward choice. And the developer UX around building async apps, if they aren't small and from scratch, is really poor. And the provocative question here is, there is this assumption underlying the design of all this, and that's like, if you have async code path, you just cannot have sync code in there, or you need to wrap it in those threads, etc. But does it have to be that way? There are, I think, a lot of small opportunities how to make those pieces of the ecosystem work better. Just as one random example, in Unicorn, if you do those async jobs and you have something stuck in one of the jobs, even if there is like four free threads, they will not pick up some other requests that have affinity to the thread that got stuck. You still have some threads stuck, even if they could have got done just because there was something bad happening in one of the supposedly async threads. Small things, small improvements like this could go a long way. And then you have the whole thing around Pydantic and Pydantic base model and data classes, and of course Pydantic also offers data classes, but then you have a really difficult time to do some things like allowing extra parameters and so on. My main issue here is it leads to further fragmentation, and it doesn't feel that batteries included is true anymore in Python. Or of course, you have batteries included, but are those the batteries you want to use? Don't you have some really lousy, low-voltage batteries included, in fact? And then is it actually a good idea to have batteries included, right? And here, actually, for example, I think almost everyone here probably uses PyTest. PyTest isn't part of Python, core Python either. We don't really notice because, in the end, everyone uses PyTest, but here it's a little more complicated because you have, this is part of the public API for your components, however you define those things. So the question is, cannot we start converging? Because honestly, this Pydantic team, I think they are doing amazing stuff. And I really cheer for them, and we really adopt what they do pretty aggressively in Rossum. It's just difficult to do in the Django part of the code base. But what I'm worried about is whether this is not leading to fragmentation in the long term. So I really hope that Python maintainers and Pydantic maintainers talk a lot behind the scenes how to start converging things together. But in the end, also, I shouldn't talk about them, because as Savannah was saying in the morning, it's not about them and us. Anyone here can start contributing to Python code base. So also consider that, especially if you are as irked about me about some of those things. In the end, this is the last slide pretty much. Zen of Python, as I mentioned, is a bit of a meme, and you shouldn't take it seriously. There are people, even people like taking things like complaining, okay, we have this PEP8, but parts of this Python standard library aren't really in PEP8. What's going on? There is so much inconsistency, and then they start bashing you that like whatever you do, the code you wrote violates this tenet of Zen of Python. Zen of Python is meant to just lead us to ask the right questions, as any Zen, right, and figure out the answer for ourselves. And it's always was meant as a bit of a joke. For example, if you import this, if we go back to the beginning of the presentation, if you import this is the source code of this module. It is purposefully designed to violate as many tenets of Zen of Python as possible, because the world is full of contradictions. And we should have some fun also while it didn't just blindly stick to rules. So have some fun. Have some fun at the conference. Thank you. Thank you to the Python maintainers for Python. And thank you all for building with Python, because that creates this amazing community that I'm glad to be part of.